Okay, welcome back to our third learning target for Unit 7. This one begins on page 9. So go ahead turn to page 9. Our learning target for today is I can use function notation. So just to let you know, today's lesson has no new math in it. I'm not teaching you a new math concept. I'm teaching you a different language, a different math language here that you're more so going to use next year than this year. I'm just introducing the basics of it this year. You're probably, as you watch this and listen to this and learn this, wonder at some point, why are we even doing this? Why not just stick with the old way? Because when you get into higher level math, it will become more apparent to you why this function notation deal is more useful than just our old way of knowing things, okay? So stick with me. Make sure that you are asking clarifying questions if you get lost at any point. So remember, today I'm not teaching a new math concept, I'm just teaching a new language called function notation, okay? So let's start off with the vocab here. What is function notation? Function notation it's a naming process for equations, okay? So in other words, it's another name for y. So we're used to using the variable y. We're going to change the function notation. It's going to change that y here. It's a naming process. Okay? What does function notation look like? Well, the old way being that the way that we're using right now, for y equals mx plus b, looks like this. You guys should recognize this. We always said y equals mx plus b. Well, what does this y equals mx b look like in function notation? Well, the mx plus b stays the same. The y changes. Remember, it's another name for y. And that y changes into a symbol that looks like f, and in parentheses there's an x. Okay? F of x, so this fx symbol right here, is replacing the y symbol. So in other words, you can see old way, there's a y. We replaced it with this symbol f parentheses x. The x, though, is still the x. It still represents the same thing. Okay, that doesn't change at all. F is the function's name. Okay, so this f right here is the function's name. F is the most common name you're going to see in function notation. You're going to often see G, H, K, but either way, it could be any letter in the alphabet. You can name any function, whatever letter you want. Okay, so how do you say this funky notation here, this function notation? Well, this symbol right here is red. When you see me say this, I'm always going to say f of x, okay? The function of x, or the function f of x. It doesn't mean f times x. So I know that you guys are used to seeing a number and then a number on the outside of set of parentheses. We always said that it was multiplying. Well, in this function notation, it doesn't actually mean f times x. It's just a symbol that represents the name of the function, and then the x is what the x is. Okay? So let's take a look at some examples. How do you evaluate with function notation? Okay, we're going to do it the old way, and then I'm going to show you the new way, the function notation. So old way, I would ask you a question that looked like this. Evaluate when x equals 2. And so you're given the equation y equals 3x plus 1. So what you would have done is taken this 2 and put it in everywhere you see an x. So you would have done 3 times 2 plus 1. 3 times 2 is 6. And 6 plus 1, well, the y equals 7. So when x is 2, the y equals 7. Old way. Well, what does this look like in function notation? I'm going to ask you the same exact question, but now in function notation language. It's going to say something like this. What is the value of f of 2? Given that the function here is f of x equals 3x plus 1. So in other words, this is the function, okay? Remember, this is the symbol for function notation. So they're telling me in the function, the name of this function is f. The x here says, what's the value? Well, notice that there's a 2 replacing this symbol here where the x was. So that means the x is going to be 2. So everywhere in this function, 3x plus 1, you're going to replace the x with a 2. So I see 1x here. So I'm going to replace that x with a 2. So I'm going to have 3 times 2 plus 1. and I'm going to evaluate this. So 3 plus 2 is 6, 6 plus 1 is 7. So that means in this function f, when the x part is a 2, the entire thing equals a 7. Okay, so that's how you would read function notation. Keeping in mind, this 2 is the x, this 7 is the y, because remember, f of x is replacing the y. So f of x is the same thing as saying the y. Okay? So let's give some a try here. I'm going to do one with you, and then I want you to finish this off by pausing it and trying on your own and checking back. Okay? So first question says, what is the value of g of 3, g of negative 1, and g of 0, given that this is a function g of x equals 2x plus 4? So there's 3 different problems going on here. I want to know in this function, what is the function equal when the x is 3? What is the function equal when the x is negative 1? And what is the function equal when the x is 0? So let's do the first one together. So in this function g, we can see that it matches the function name when the x is 3. So I'm going to do g of 3. So everywhere in my function here, 2x plus 4, wherever there's an x, I'm going to put a 3 in. So I'm going to do 2 times 3 plus 4. This is 6 plus 4 equals 10. That means in this function g, the name of the function, when the x is a 3, the entire thing equals 10. So there's your first answer. Why don't you go ahead and pause this and give g of negative 1 a try, and give g of 0 a try and see what you get for those 2 answers. Okay, let's take a look at what you got. So g of negative 1. So in this function of g, when the x is negative 1, I'm going to put a negative 1 wherever I see an x. So this is why over here there's an x here. I have 2 times negative 1 plus 4. Did the math, it all equals 2. So that means in the function g, when the x is negative 1, the entire function, when I put in x equals negative 1, equals 2. So that would be your y. Okay? And the g of 0, in this function of g, when the x is 0, put in a 0 wherever an x appears. 2 times 0 plus 4, I did the math, so 0 plus 4 equals 4. That means in this function of g, when the x is the 0, the entire thing equals 4. That would be your y. Okay? Go ahead and try this last one on your own and then check back. All right, let's take a look at how you did. It says find the value of h of k equals 4k plus k when k equals negative 1. So the function name is h, okay? They're telling you that the k equals negative 1. So I'm just going to say, hey, they want the k to equal negative 1. Notice it's not an x here, so it's just, we're trying out different variables here. So in this function, 4k plus k, everywhere there's a k, you have to plug in a negative 1. So we're going to have 4 times negative 1 plus negative 1. And let's go ahead and evaluate it. 4 times negative 1 is negative 4, plus negative 1. Negative 4 plus negative 1 is negative 5. So that means in this function of h, when the k was a negative 1, the entire thing equaled negative 5. Okay, so this would be your final answer. If you just left it as negative 5, I'd be totally okay. All right, make sure you're pausing and asking for clarification, or you need to rewind and listen to that again before we move on. Please do so. Otherwise, let's go ahead and move on to the next page. All right, now we just evaluated. Next part is, how do you solve for x in function notation? Okay, so old way would have been this, solve for x. 6 equals 2x minus 10. Well, you guys would have used SADMAP, inverse operations. You would have added 10 because it's a minus 10, so you got 16 equals 2 times x. Then you would undid this by dividing by 2, and 16 divided by 2 is 8 because that canceled out. Okay, so that would be the old way. What does this look like then asked in function notation language? Well, this way, function notation language would have asked this. Well, the function, the name of the function is f, so f of x equals 2x minus 10. So there's your function, 2x minus 10. Solve when f of x equals 6. Okay, so in other words, they're telling us that this symbol, f of x, equals 6. So wherever I see the symbol, right here, I'm going to use a 6 in place of that symbol. Okay, so in other words, instead of saying f of x equals 2x minus 10, I'm going to plug in this 6 for this entire symbol right here. And then I'm going to write 2x minus 10. Okay, because f of x equals 6 when the entire function equals 6. And then we have an equation that's set up exactly like this. You would just solve it like normal. I'm not going to do all the work again. I already know that x equals 8. So your answer for this type of question is 8. Notice that the 6 is not inside the parentheses anymore, because this one you're actually looking for the x when the entire thing equals 6. Okay? So if you wanted to rewrite your answer back into function notation, you would write, in this function, the x here we found was 8, so we found this x, and when this function, when the x equals 8, the entire thing equals 6. So if I were to put an 8 in for this x here, 2 times 8, 16. 16 minus 10 equals 6. Okay, so it's just backwards. This time that the number isn't inside that first set where the function name is. Let's try another one. For the function of h of x equals negative 7x, find the value of the x. So find the value of x so that h of x equals 14. So in other words, they're telling you h of x equals 14. So here's h of x. It equals 14. So what I'm going to do is I'm going to write 14. This equals 14 equals negative 7 times x. Let's go ahead and solve this. I'm going to divide each side by negative 7. 14 divided by negative 7 is negative 2. So that means my answer is x equals negative 2. I just found the value of x. How would you put this back into function notation? Well, I would just take this and I'd plug in my negative 2 where the x is. So that means in this function of h, when the x was negative 2, the entire thing equaled 14. Okay? All right. See if you can go ahead and give the bottom two problems a try. Pause it, and I'll explain them to you and see if you got them correct. Okay, let's see how you did here. For the function f of x equals 5x plus 10, find the value of x, so you're finding x, so that f of x equals 37. So they're telling you this piece right here, f of x, it equals 37. So let's replace that with a 37, the entire thing. It doesn't say x equals 37, it says f of x equals 37. And on the other side is 5x plus 2. You should have done the math, so subtract 2 and divide by 5. You should have gotten x equals 7. And you can leave it at that if you want. If you want to rewrite it back into function notation, you would have filled in this x right here with the 7, because that's what you found x to be. So you would write in this function, when the x was 7, the entire thing equaled 37. That means if I put a 7 back into here, 5 times 7 is 35. 35 plus 2, the entire thing equals 37. Last one here, given h of x equals negative 3x plus 4, what is the value of h of x when the entire thing equals 16? So I'm going to replace this whole piece right here with a 16. So 16, and then equals whatever this function is, negative 3x plus 4. I'm going to use SADMAP to solve here. So minus 4 and divide by negative 3. We're going to get negative 4. So final answer is negative 4. Again, if you'd like to put it back into function notation, this would read, in this function of h, I found the x to be a negative 4. Okay? When the entire thing, when the x is negative 4, the entire function equals 16. And that 16 right there, all I did was replace this x with what I found x to be. That means if I put in negative 4 for this x, it should equal 16. Negative 3 times negative 4 is 12. 12 plus 4 is 16. Okay? So again, ask clarifying questions here, please. Let's go ahead and close with a summary. So keep in mind today, the notation, function notation, it's just the language that we're learning, not the math part. F of x is replacing the y. Okay, so in other words, old way would have been y equals 3x plus 2. Well, now you're going to see f of x equals 3x plus 2. The same thing here. Okay? And this is the most important part, how to be able to interpret what's being asked here. Now keep in mind, let's say I wanted f of 17. Okay, so in other words, this means you're actually finding what the y equals when the x equals 17. So it'd be like putting the 17 in these x's so you can find what the y is. Okay? The other type of question then would be f of x equals 17. Notice the 17 swaps places here. Okay, it's not what the x is. This means that you're actually finding what the x is when the y equals 17, when the entire function equals 17. So for example, on this one, you would replace this entire thing with a 17, or think of this, replace that with a 17, and you'd use SADMEP to look for the x. Okay? All right. This lesson is going to take some practice in order for you to get, so please make sure you are putting some sort of practice into it, because what I just showed you is not enough exposure to you to help you understand this completely. Okay, so practice starts on page 11. Go ahead and get started, ask questions, check your answers. Good luck.